Welcome to the Daily Space Weather. We've got a coronal mass ejection, a large, significant, magnetically complex sunspot group rising, and more to cover. Let's get to it. This is Sunspot 2886 right here. It's not very interesting. This sunspot group down here is very interesting. The likelihood of major solar flares much higher. And we indeed saw a coronal mass ejection. We can expect to see more in the coming day or two. So here's the coronal mass ejection we're talking about. These views are from Stereo A, which is on your left, and the SOHO-LASCO C2 on your right. This coronal mass ejection activity is not Earth-directed. Here are the locations of these spacecraft. Lagrange point 5 is where Stereo A is located. And Lagrange point 1 is where the SOHO-LASCO C2 is located. You can see that coronal mass ejection likely to miss the Earth well to the west. Let's continue on with some more imagery here. Colorized magnetograms next. This area here, not a sunspot. Once again, it has not had consistent umbra for 12 hours in a row, basically. This active region rising down here, Sunspot 2887, likely to be named, is quite magnetically complex already. It's got a number of umbrae. One of them is very large. We'll show in-depth information about that toward the end of the video. So here's a bunch of ionized helium, 304 angstroms. And there is a coronal mass ejection. You'll see a brief flash right there. That was the coronal mass ejection leaving the solar corona. Here's just the southern hemisphere where most of the activity is currently located. Again, solar flare warning in effect as a result of this large group rising. Here's a close-up of it. And Sunspot 2886. Some great imagery there from the Solar Dynamics Observatory. The radio flux has come up to 82 solar flux units. And for you new viewers out there, the radio flux is the most proportional data set we've got to sunspot number. Here it is in context. It's a one-year chart. It needs to be refreshed as it will be up here above 80, but that's 1 year of the radio flux, the black line there. The red line is the sunspot number. We can expect to see this rise precipitously with a whole slew of umbrae rising in the southeast. So there's a space weather enthusiast dashboard. No space weather storms currently in the forecast. Let's take a look at global seismicity briefly. Quite a few earthquakes in Alaska over the past 24 hours. Also a 4.6 at Greece. Pretty much seismically calm here over the past 24 hours. Not a lot of activity at all. Largest quake of the past 24 hours was a 5.6 at New Zealand, I believe. That located at a deep depth. 223.1 kilometers estimated depth for that 5.6 magnitude quake. Indonesia saw a 5.3. Micronesia saw a 5.4, and Fiji saw a deep quake at nearly 600 kilometers while we did show prep. A 4.3 magnitude quake there at nearly 600 kilometers depth. Guess what? Etna is still erupting. There's some lava fountaining from the Italian Aeolian volcano, Sicilian volcano. So after 1 month since the latest paroxysm, it's back to erupting once again. Sporadic ash emissions, glowing steam and gas plumes. Producing about a 9,000-foot plume of volcanic ash there. La Palma continues to explode as well, or at least erupt, as evacuations happen in the Canary Islands. Suwanosejima, flight level 060 there, a 6,000-foot ash plume produced over the Ryukyu Islands by Suwanosejima. And the tallest ash plume produced on the Earth here is produced by Manam, Another 50,000-foot ash eruption there from the Papua New Guinea Manam volcano. Also, Yasur, located on the Vanuatu island of Tanna. Low-level eruption from Yasur. Kilauea, now on the list. An effusive eruption happening there at the Halemaumau crater. That was not named by George Lucas. Halemaumau crater has nothing to do with Disney. Sulfur dioxide emissions remain elevated from Kilauea. Semisopochnoi, volcanic ash information not provided by the Volcanic Ash Advisory Center, Washington. Fuego exploding, flight level 150. Nevado del Ruiz exploding, flight level 190. That's a 19,000-foot ash plume over Colombia. Sangay exploding, producing a 19,000-foot ash plume over Ecuador. Revenador exploding, 15,000-foot ash plume over Ecuador from Revenador. Sabancaya exploding, 25,000-foot ash plume over Peru from Sabancaya. Please don't pole vault the caldera. Please do visit the links and support the channel, whether you're just pressing like and subscribe, or if you're actually opening up your cobweb-encrusted wallet and dropping some cash, maybe joining the Smash team. You can find links to it at smashomash.com. Today's featured product is Let's Go Brandon. Let's go, Brandon. I'll just leave that there. Celebrating the Dimension of the Year. That's the 2020 unanimously voted Dimension of the Year. Go pick up some merch. You can find a link right there. The SMASho merch link on the homepage at smashomash.com. Welcome to the Neo-Renaissance. Sorry about all the nonsense you've probably watched on YouTube and other places on the internet. We won't produce any. Let's get a look at some magnetic data here. Here's the 3-day chart as measured by the GOES 16 and GOES 17. Some arcjet moments here. In fact, one is in progress as we speak. That is caused by the GOES 17 turning on its thrusters to make sure it's maneuvered to the correct location, a geosynchronous near equatorial orbit. And those engine thrusters produce plasma, which can affect the magnetometer data. That's why they help you out by showing you the arcjet start and end moments. And let's look at the magnetic environment of the heliospheric current sheet. There is a North Pole current sheet speeding our way, folks. As we forecasted yesterday, you can now see it headed our way. It's made its way past stereo A, located right here at Lagrange point 5. North Pole current sheet making its way to Earth. So here's the line of sight plot. You can see this blue line being pulled way down toward those two major sunspot groups in the southern hemisphere. No big surprise there to our regular viewers. Here's the line of sight coronal hole plot showing you the sun's B field in blue. In magnetohydrodynamics, folks, the B field is the field that goes through the magnet, and these potential field surface source lines shown in blue are the sun as the magnet. You can see a bunch of significant red-colored, south-oriented coronal holes there. There's the latest image. And if we go back several days, we can actually see this coronal hole progressing. There's about a week of coronal holes. Just awesome imagery there from the Solar Dynamics Observatory in 193 angstroms. Here's today. And here's the flare monitor. Expect to see this go way up. The likelihood of major flares really high at the moment. We'll issue a solar flare warning associated with this rising sunspot group 2887. Also, coronal mass ejection warning. So we're back to a solar flare and coronal mass ejection warning, folks. Here is the flaring profile over the past 3 days. No major flares here, not even anything into the C range. Expect to see that change soon with that rising region. No spikes in the proton flux, no surprises to our regular viewers. We forecast coronal mass ejections before they exit the solar corona. Let's take a look at what's going on at Lagrange point 1. The measurements of the real-time solar wind by the ACE and Discover spacecraft. Current solar wind density only about 4.9 protons per cubic centimeter. Solar wind speed still elevated here a bit, 464 kilometers per second. The rest of it fairly unremarkable. KP index at 0. Geomagnetic extremely calm conditions. Here's the geospace over the past 4 hours as modeled by the Space Weather Modeling Framework. This is modeling nanopascals, which is magnetohydrodynamic pressure. This data courtesy University of Michigan Geospace Model V 2.0. And we're seeing fairly homogeneous pressure, at least as according to the Space Weather Modeling Framework. Here's the other Space Weather Modeling Framework data. It's geospace delta B, changes to Earth's B field. We show it daily because of Earth's geomagnetic excursion, polar excursion, magnetic excursion, whatever you want to call it. I'm not frightened in the slightest. Magnetic excursions are probably constantly occurring. They're like climate change. They're always a thing, and they're never static. Anyway, that's 4 hours of data. Changes to Earth's B field, geospace delta B. Here's where stuff's located in the solar system. We'll advance this 1 week. There's where things will be on October 29th, 2 days from Halloween. Do you have any exciting plans? Here is the star chart of what's going on above my head. It's in the-sky.org. Mine faces the south. I've drawn in the ecliptic, which is the yellow line, on which the moon is located. The blue line is the galactic plane. We've also shaded in the galaxy. Where will you be when Cygnus sets? Let's do a brief cosmology segment. This one's going to have some interesting data in it. If you want to see some more interesting data, check out our playlists, youtube.com/smashamash/playlists, for over 200 cosmology segments. Why did human brains decrease in size 3,000 years ago? Well, I'll tell you right now why. It's because of society. It's because brains are very costly, and having big brains costs a lot of energy. And costing a lot of energy costs a lot of food. And when you have a civilization, people are able to be more specialized and have smaller brains. Yeah, so the brains shrunk about 3,000 years ago because of collectivism. Don't let your brain shrink due to collectivism. Make sure you continue to think for yourself, as the necessity for centralized anything gets lower and lower. Centralization is dead, folks. And while it does enable you to, from an evolutionary perspective, conserve energy, it's not good for your brain development. So highly recommended that yours doesn't shrink because of collectivist nonsense. Yeah, collectivism is why the brain shrunk 3,000 years ago. Read the article if you don't believe me. Here's apod.nasa.gov. It's the astronomy picture of the day showing M1, the first object in Messier's catalog of things that he said, these are definitely not comets. Or you could say wandering stars. Yeah, the Crab Nebula, fueled by the Crab Pulsar. And that's a comet right there that I'm not going to attempt to call anything besides Rosetta's Comet. It's also known as Churyumov-Gerasimenko. Anyway, great imagery there of some objects located in Taurus, the location of the Crab Nebula and Pulsar. apod.nasa.gov if you want to check that out yourself. Today we're not featuring a random object at all. We're going to look at cosmic ray monitors instead. So first we're looking at the Apatity and Barentsburg neutron monitors to show you an uptick here over the past 30 days at Apatity in cosmic ray flux. There you can see this uptick. It's minor. It's noteworthy. Barentsburg showing a downtick of a similar magnitude, an even steeper downtick actually at Barentsburg. Let's go farther south to Greece. Here's what's been going on at the Athens neutron monitor over the past 30 days. Almost completely flat here over the past 30 days at Athens. Even farther south, we'll go to Mexico City's Cosmic Ray Observatory. Minor downtick there at Mexico City. And let's go back up north to Oulu, Finland. There's Oulu, Finland. And you can see an uptick at Oulu, Finland over the past 30 days. Let's check Antarctica. DOMB showing a slight downward trend over the past 30 days. DOMC Antarctica showing a similar downward trend over the past 30 days. That's cosmic rays. Let's talk more about cosmic rays. You know, sometimes cosmic rays are a result of protons colliding with other protons. Other times, cosmic rays are caused by, well, gamma rays, I should say. Sometimes gamma rays are caused by protons colliding with protons. Other times, gamma rays are caused by electrons colliding with photons. Two very different processes. One hadronic, one leptonic. And there's an article in SciTech Daily about it today. By the way, it's not very well known about cosmic ray point sources. One of the only known cosmic ray point sources, if not the only known one, is Deneb Cygnus X3. And it's about a 70-30 split, so about 70% of gamma rays from space are produced by hadronic processes, that is, protons colliding, and the other 30% are electrons colliding with photons through reverse Compton scattering. I won't get into that, but another article here about cosmic rays on SciTech Daily, solving a 100-year mystery. Astronomers locate source of high-energy cosmic rays. They're talking about gamma rays here, not the mostly hydrogen nuclei that make up most cosmic rays. And those are traveling around the speed of light, folks. Relativistic protons are the primary cosmic rays. And that's today's cosmology segment. We hope you enjoyed it. It was integrated into the Daily Space Weather. For those videos that are separate, youtube.com/smashamash/playlists. Let's blast through more data. We don't see any charging hazards at the moment. Here's the electron flux over the past year. You can find that graph yourself if you like at solon.info/solar. Here's a 3-day chart. And I was pretty much correct here with my forecast for the electron flux. I was kind of right on that one yesterday. And I would tend to agree with the incoming forecast here. We're expecting some higher levels of electron flux. Let's take a look at Earth's electron densities. Here's a diagram of the Earth's Van Allen belts. And here is the total electron content. And we're seeing low levels of electron flux here. So this data pretty much corroborating with the GOES 16 and GOES 17 measurements. They're measuring the electron flux at the Ionosphere layer. This is the entire total air column. Next, we'll look at the ionosphere. The Ionosphere located at about 300 kilometers of altitude. Here's the ionogram. Lots of low pressure anomalies north of the equator. As the northern hemisphere descends into winter, will it be as cold and as dark as it was last year? That is the question. By the way, happy Smashtober. Here's the latest image from 9 o'clock Universal Time. Here's the anomalygram showing departure anomaly in megahertz from the 30-day median. It's showing you low-frequency anomalies in red and high-frequency anomalies in blue. Significant low-frequency anomalies here north of the equator, like I said. Here's the latest image. That's 9 o'clock Universal Time. There you can see some low-frequency anomalies on the west coast of Africa there, spreading into the central Atlantic Ocean. Here come bonus features. Let's press refresh and see what we're going to look at. We're going to look at the El Teide ground-based solar observatory here, looking at hydrogen alpha, 6,562.8 angstroms. And you can see activity over here from Sunspot 2887, the massive group. It's got a ton of umbrae. And here's the latest. Let's also refresh the colorized magnetogram. Check it out. Look at all the umbrae there. I mean, at least 6 of them. That is a beta class sunspot all day. Sunspot 2886, not so exciting. It's alpha class. So only one polarity there. And here, multiple polarities. And we're seeing sunspots at different latitudes once again. So the ability for these magnetic fields to interact with each other and so on is quite high, enough to create a solar flare and coronal mass ejection warning. Here's some composite imagery to close out the video. This is 193 and 171 angstroms, two different ionized iron spectra. It's ultraviolet light. Here's a close-up in those same wavelengths. Great imagery there of that rising region. And we'll close out the video with my favorite wavelength separated, 171 angstroms, the low corona ionized iron ultraviolet emissions. Thanks for tuning in. Congratulations on realizing our channel exists, and may that solar wind be at your back.